Hello students, how are you all? Hope you all are doing great and giving good enough time to your studies. I, Rekha Chabra, your maths teacher, welcome you all to my YouTube channel Learn Mathematics. Students, before I start, I would request you all to please like, share and subscribe this channel if still not done. So, students, as you all are already aware that objective questions play a very important role in our examination nowadays. So, in today's lecture, I'm going to discuss few short questions in this revision video too. So, let's start. If R is equal to a comma a cube, where a is a prime number less than 5 be a relation, then find the range of R. Here the ordered pair is given as a comma a cube. Is a prime number less than 5? We know that there are only two numbers 2 and 3 which are prime and less than 5 as well. It means a can take these two values. So the relation, if we write down in roster form, it will be 2 comma 2 cube means 2 8, or 3 comma 3 cube means 3 and 27. So what is the range? 8 and 27 is the range. Question number 2. Here function f and g are defined from one set to another, and f is given as 1 2 3 5 4 1 and g is given as 1 3 2 3 and 5 1. Write down GOF. GOF means the composition of two functions. It means g of fx. So basically we have to find GOF for 1, 3 and 4, because what will be the domain for this function GOF? It will be the domain of function f. So we have to find GOF of 1, GOF of 3 and GOF of 4. So GOF of 1, first of all, it is g of f1. What is the answer for f1? f1 is 2. So it means g of 2. Now what is g of 2? g of 2 is 3. So the final answer for GOF of 1 is 3. Same way you can calculate for GOF of 3 and GOF of 4 as well and give the final answer. Question number 3. Let R is the equivalence relation in this set A given by this AB ordered pair where 2 divides A minus B, means the difference is divisible by 2. We have to find the equivalence class of 0. It means we have to look for the numbers which are related to 0. So definitely all the even numbers, all the even integers are related to 0. So it means 2 and 4. So these two numbers come under the equivalence class of 0. Question number 4. Here relation is given as xy, x plus 2y equal to 8 is the relation on natural numbers. We have to find the range of this relation. Now first of all we will write y in terms of x. It means 8 minus x by 2. Now one by one let's calculate, let's put the values. X is equal to 2. So y is 3. If x is 4, so y is 2. And same way if x is 6, y is 1. As x, y both belongs to natural numbers, so the relation will be 2, 3, 4, 2 and 6, 1. So the range is 3, 2 and 1. Question number 5. If A and B sets are given and function is given as 1, 4, 2, 5 and 3, 6, we have to check whether the function is 1, 1 or not. Here students, it's clearly visible that all the elements of set A are having a unique image in set B. Means 1 is mapped with 4, 2 with 5, 3 with 6. So images of distinct elements of A under F are distinct. So F is definitely 1, 1. Question number 6. If function is defined from R to R, means real number, and the function is given as 3x plus 2, then what is f of fx? Now f of fx means we have to take f of fx, means f, and then in place of fx we have to write down the given function which is 3x plus 2. Now we have to treat this function as again fx. So 3, and in place of x we will input this value 3x plus 2 and plus 2. Open it, solve, and the final answer is 9x plus 8. Question number 7. Write fog if function is defined f r to r, g also r to r, and they both are given like this. This is question of your NCRT and we have discussed earlier also. So we have to find fog x. Fog x means f of gx. Now what is gx? Mod of 5x minus 2. Now we have to treat it as fx. So what is fx? Fx is mod of x, means we will get double mod. So if we apply 2 mods or 50 mods or 1 mod, it means the same thing. So it means the final answer is mod of 5x minus 2. This is fog x. Question number 8. Write fog if f is defined from R to R, g is also defined from R to R, and functions are given like fx equal to 8x cube and gx equal to x raised to the power 1 by 3. We have to find fog x. It means f of gx. So first of all, let's replace this gx with the given function, which is x raised to the power 1 by 3. Now let's treat it as fx. So what is the function fx? That is 8x power 3. So 8x, what is x here? X raised to the power 1 by 3, and this thing power 3 because it is 8x cube. And what is x here? X is x raised to the power 1 by 3. So x raised to the power 1 by 3, we will treat it as x and whole raised to the power 3. And this will be cancelled and the answer is 8x. Question number 9. State the reason for the relation R in the set this 1, 2, 3 given by this not to be transitive. So we know that for a relation to be transitive, if xy belongs to R, yz also belongs to R, so xz should be there in the same relation. Here we have 1, 2, we have 2, 1, but do we have 1, 1? No, it is not there. So that reason only we have to give here. If they ask whether the function is symmetric or not, so yes, the function is symmetric because if 1, 2 is there, so 2, 1 is also there. But this function is not transitive. Question number 10. What is the range of this function? Wherever we get mod, so that question becomes automatically important. So given function is fx equal to mod of x minus 1 upon x minus 1, where x is not equal to 1. Let's define this function. We can write it this way: x minus 1 upon x minus 1 when x is greater than 1, definitely, and it will give us negative of this thing when x is less than 1. So it means x minus 1 upon x minus 1 is 1, and x minus 1 minus x minus 1 upon x minus 1 is minus 1. So what is the range of this function? The range of this function is basically minus 1 and 1 only two numbers. Whenever x is greater than 1, it is going to give us 1 as answer, and whenever x is less than 1, it is going to give the answer as minus 1. Now, few questions are given in the form of assignment, few short small questions only. I would request you all to please try all these questions yourself. You can pause the video, note down the questions and please try yourself. Thank you students. Thank you very much.